Okay, so now at this point, we ended up leaving this equation as 3y equals. Well, we need to make sure that we cancel out the 3 by dividing each and every term by 3. Doing that, 3 divided by 3 is 1. We're going to leave this as 2 over 3. And negative 12 divided by 3, if you try that in your calculator, it turns out to be negative 4. So your slope is a fraction, which is kind of nice. And your b is a negative 4, not positive 4. If you make that mistake, you're going to run into problems. So because the slope is the rise over the run, we're going to rise up 2 and go run out 3. So from negative 4, which is down here, we're going to rise up 2 to the right 3. So you keep doing that. Okay, until you can't anymore. So we're, instead of going up 2 and to the right 3, we're going to go down 2 and to the left 3, so that I could draw a line, a nice line going through all of these coordinates. Okay, and label this line with a B. As you can see, the point of intersection is pretty clear. It's right where the 2 points meet. And those 2 points meet when x is equal to 3. X is always first. And y is equal to negative 2. So the last and final thing you need to do is write your therefore statement. Therefore, the point of intersection is 3, negative 2. So that is for question B. So we're going to go ahead and finish one more practice, and then you can do the worksheet. In this case, both equations are not in y equals mx plus b form, which makes it a slightly more difficult because you have to rearrange everything. So what we're going to do is start by rearranging the first equation, and I'm just going to go ahead and call it A. Okay, so if I do that, I'm going to call 4y plus 4 equals negative 3x, and I'm going to call that A. So in order to have the y completely on its own, you need to make sure that you cancel out whatever is around it. So the plus 4 needs to go by doing minus 4 on each side. So that cancels that out, but it doesn't cancel it out on the right side. So we have negative 3x minus 4. At this point, we need to divide each term by 4. So if I do that, I get negative 3 over 4x, and 4 divided by 4 is 1, but because there's a negative in front, it's actually negative 1. So in this case, we're going to write down our m, which is negative 3 over 4, and then we're going to write down our b, which is negative 1. I'll start by drawing my b, because you can, but to get more coordinates, you need to recognize that the slope is rise over run, which means we're going to rise down 3 and to the right 4. So when I do that, I rise down 3 and to the right 4, I end up only able to draw 3 points. So to do the opposite, I'm going to go up 3 and to the left 4. Okay, just like that. So when you draw your line through it, oops, just make sure that your line is straight and that you have arrows with an A labeling that A is the work that you just did. Now B, for me, is going to be in pink, and that equation is also not in y equals mx plus b since it's in standard form. So we're going to want to find the 3y completely on its own by subtracting 9x on both sides and by also subtracting 3 on both sides. So when I do that, I'm left with 3y equals 0 minus 9x minus 3. And I don't really need the 0, so I'm just going to start by dividing everything by 3. I'm going to scratch out that 0 divided by 3. If you try it on your calculator, 0 divided by 3 is 0. So we end up with y equals negative 9 divided by 3 is negative 3x. And negative 3 divided by 3 is negative 1. So we get an equation that is in slope y-intercept form, which means we can label the slope, which is negative 3, and we can label the b, which is -1. But the slope is rise over run, which means we need to create a run by adding an over 1 here. So we're going to start at -1, and we're going to go down 3 because it's rising down, and to the right 1. Rising down 3, 2, 3, to the right 1. And that's as far as I can go. And then instead of going down 3 to the right 1, we're going to go up 3 to the left 1. So when you do that, get a nice line that crosses, in this case, on the y-intercept. And the y-intercept here is 0, -1. So there's only one y-intercept, but two different lines. And the y-intercept is 0, -1. And we're just going to write that, therefore, the point of intersection is 0, 1. So, -1, 0, -1. So when you're drawing the y-intercept, you want to make sure that the x value is always 0. We saw that in class. So it's up to you to make sure that you label exactly what the question is asking. If you go back up to the top, it tells you right here. So this part here, convert all linear relations into y = mx + b form. Graph and label all of the equations, so that's 2 equations. Label the shared point, and then you write your therefore statement. So I'm looking for all of those 4 things in your solutions. So going down to the worksheet, all equations here are in y = mx + b. So it actually makes your work just slightly easier for the first page. But then the second page, they start tricking you at question 7 and also question 8. So a few of them, and 9 and 10, sorry. So 7, 8, 9, and 10 are all questions that you have to isolate the y variable. It doesn't matter if the y variable is on the right side or the left side. So just do your best to do these questions, and the answers are at the bottom. So when I come around and pick these up, I'm going to make sure that you're able to graph properly and able to isolate your equations properly.